Okay, the Chapter 4 and 12 sample test. Com- Compare the following investments by calculating the APY, the annual percentage yield for each, as well as the total amount of the investment would be after 20 years. The amount you want to invest is $3,000 and the APR of 5%, compounded annually. So we're going to pull out the compounded formula, which is this one. Compounded annually, so n would be 1, and we're starting with 3,000, that's the principal, and the APR is 0.05. So I'm going to fill that out. 3,000 move it here so you can see it. 3,000. Come on. Too many things on my desk here. Times 1 plus APR 0.05 divided by 1 for annually to the 1 times 20 years. I'm going to work that out first. And that would be how much I have after 20 years. And that works out to be I'll move that up so you can see the calculator better. On clear, 3,000, parenthesis 1 plus 0.05 divided by 1 is 0.05, to the power of 1 times 20 is 20. And I get 7959.89. So the 3,000 has gone to 7,000. Now what's the annual percentage yield? So that's the percentage yield over 1 year. So if I work this out, it'll tell me what I have to multiply 3,000, but I want to do it for 1 year. Okay, well, since it's annual, and if I put a 1 here for 1 year, this number would be 1 plus 0.05 over 1 to the 1 times 1, and that would give me 1.05. So the yield would be 100%, the yield would be the 5%, so it's only 5%. It will be equal to the APR. Now, the other way to do it is to figure out the whole thing for 1 year. Even if it was compounded monthly, I'd put a 12 here, but it's 1 year, so I'm going to do this. I do the whole thing with just a 1 instead of a 20. So if I change the 20 to a 1, I'd have 3,150, which has increased by 150 over the 3,000. So my yield is $150 out of $3,000 times 100 to make it a percent, and I would get, see, 2 zeros will cancel, 30 in that, I get, well, I'll work it out this way, 150 times 100 divided by 3,000, and I get 5%, because I've multiplied by 100, so that's 5%, which that's what it was. For APR is equal to APY for compounded annually. Now, if it was monthly, it would be different, or daily, or quarterly. Compounded continuously, it will have a different APY. So the amount I have after a while, after 20 years, so now I'm going to use the compounded continuously formula, and I'm starting with $3,000 still. E, the APR is 5%, so 0.05. Don't forget to put it in decimal form when you do your test, for 20 years. And that works out to be, where you can see it, it doesn't show up over there very well, 3,000 e to the 20 times, let's do it in the order, 0.05 times 20. And I get a yield of, not a yield, but the value of the 3,000 will be 8,154 and 85 cents. Now to get the annual percentage yield, I got to figure out how much the 3,000 turns into using this with a 1 for the number of years for annual. Now if I do just that, I'm going to leave the 3,000. I'll show you how to get it the short way. Then I'll do it the long way. E to the 0.05. Close parenthesis. And times 1, so I don't need to do it times 1. And that's 1.05127. So it tells me the annual percentage yield is, we get the 100% back and 5.127% more. So the annual percentage yield is 5.127%. Now I can get the same answer by doing the whole thing, 3,000 times that, 3,000 times e to the 0.05 times 1 year for annual percentage yield. And I get this, which is 3153.81. So the 3,000 has grown by $153.81, and I divided by the starting amount, 3,000, and times 100 to make it a percent, and I should get 5.127. Let's make sure. So I have this minus 3,000. There's the 153.81 divided by 3,000. And I've got that times it 100 to make it into percent. Oop. Times 100. And I get 5.127% yield. That's the APY. And then the last question on that one is how much greater and by which is greater and by how much? Compounded continuously is greater. And by how much? So I'd have to subtract these two amounts. So I'd have the 8154.85 minus 7959.89 by $194.96. Okay. Next question. How much would have to be paid monthly into a retirement fund to have $250,000 after 35 years if it has an APR 6%, and I'm doing this monthly? So this is again savings now of these formulas. This is savings, savings, savings. And these are buying payments on loans and amount of loans. So the second two are loans. These are the savings, and this is one that has payments. So I want the amount at the end to be $250,000. And I want to know how much the payment would have to be. So that's what I'm trying to figure out, PMT. And that is times, according to the formula, 1 plus the APR, 0.06 over monthly 12. And that's that much. That part is to n times y. N is 12 times y, the number of years, is 35, minus 1, close parenthesis, over APR divided by n. And if I figure out this number, it'll be times this, and I'll divide it into here to get the payment. So let's see if I can figure out that number. So I have parenthesis, 1 plus 0.06 divided by 12, close parenthesis, to the open parenthesis, 1, 2 times 3, 5, close parenthesis, minus 1, close parenthesis. That should be my numerator. And if I divide it by this, divided by open parenthesis, 0.06 divided by 12, close parenthesis, I get this whole number. That's 1424.71, and I have to divide that into 250,000. 250,000 divided by my last answer, and I get the payment, the amount I would have to put away each month for 35 years, $250,000 would be $175.47. Okay, next question. So we got different kinds of investments: stocks, savings, and mutual funds. And so stocks, a low, medium, or high risk. They're considered high risk. Savings are considered low. And mutual funds are kind of in between. They're on the low side of middle, medium to low. Okay? Rate of return. Even though they're high risk, they tend to, if you don't have to sell them right away, you can get a fairly high rate of return, but it's risky. Savings is a low rate of return, and mutual funds, again, are kind of in the middle. And how easy is it to get it? That's called liquidity. How easy is it to get your money out? Well, if the stocks are down, you can't take them out or you suffer big losses. So they're not very liquid. They're low liquidity. Savings, you can take them out anytime you want. So they have high liquidity. Mutual funds, again, are in between. Yep. Next page, if I can get the page to move here. Come on. There we go. 800 a week. So gross, and works 50 weeks a year. So what is his gross annual? Well, that would be 800 a week times 50 weeks, which is 40,000. So what's the gross monthly? We did this in project 3. So the gross monthly is just that divided by 12, which is approximately. So what's the net annual? Now, I don't know if we need it, so maybe I don't need to write this. Let's see. Oh, their pay deductions is 22%. So now we're going to do this. So if they make 40,000 and they take away 22%, then they get to keep 0.78%. That's 22% from 100% is 78%. So the net annual, what they get to take home, is 31200. So the net monthly is that divided by 12, which is $2,600 a month you get to take home. Okay. So that's kind of the table I had you to do before. Now, he has a $150 credit card debt at 8%, and a car loan of $6,000. He just took out at 3% for 4 years. His estimate's a bit. He wants to buy a quad. So how much more can he borrow? Okay, so the total of the loans is 20% of the net annual. I believe that's what it was. So it's 0.2 times 31200. He can have total loans of 6,240. And his payment can be 10% of the net monthly. So the net monthly is 2,600, so that would be 260. So he wants to buy a quad. According to him, how much can he afford to borrow on the quad? And so the amount he can afford to borrow, well, he's already got a loan of $1,500 in credit cards, plus another $6,000 in a car loan. So that makes the amount he's already borrowed at $7,500, which is already over his maximum loan allotment. So he can't borrow anything. Unless they go to a high-risk credit card company, which would be really high interest rates. Okay. Could he afford any payments? Let's go ahead and figure that out anyway. So how much is the payment on the credit card? So if we use the payment formula, that would be, it's equal to how much the loan is. Computer blocked me out here. Just give me a sec. Okay, make sure you can see it. That's what I'm checking here. All right, so the payment formula says the amount of the loan, and the credit card loan was $1,500 times APR. The credit card APR was 8% over 12. All that divided by 1 minus 1 plus 0.08 divided by 12 to the negative n, that's 12, times the number of years. The credit card is so we don't have it, and so actually I shouldn't be doing this one because the credit card is usually the minimum. Well, we don't know that for sure. It's usually something like 2 or 3%. So $1,500. Remember, from our credit card project, it's times 0.0, let's say 3%. So the credit card minimum payment would be $45. So instead of using this, because we don't know how long credit card payments last forever, so we're not going to use this formula. It's going to be probably $45 or so. And then now we use the formula for the what's the other loan? A car loan, 3% for 4 years, 6,000 at 3% over 1 minus parenthesis 1 plus 0.03 over 12 to the negative 12 times years was 4 years. And that will figure out the payment. So let's see what the car payment is. So 6,000 parenthesis 0.03 divided by 12 close parenthesis, that's my numerator, divided by, open that denominator, 1 minus, open the next one, 1 plus 0.03 divided by 12, close that parenthesis, to the open parenthesis, negative 12 times 4, close that parenthesis on the power, and that should do it. So the payment on the car is $132.81. 45 minimum payment on the credit card. So that's a total of, in payments, 177.81. Monthly payments can be up to $260. So there's room for monthly payments. If you subtract that from that, they can afford to have monthly payments, but they've already overborrowed it, so they can't borrow for the car because they've maxed out their loan amount. Okay? All right. Next question. Smiths earn about $75,000 gross a year. And they can have about 23% annual deduction. So to get the net annual, you would subtract that from 100, 23%. From 100 is 77% of the total, 75,000 times 0.77. That's what 0.23 from 101 is. So the net annual income is 57750 divided by 12 tells us the monthly is 481,250, and the gross monthly is the 75,000 divided by 12, which is 6,250. Okay, the maximum loans is based on 20% of the net annual, and it comes out to be, see, that was that number times 0.2. Maximum loans 11,550. Maximum total loan payments, that's 10% of the monthly, which would be 481.25. And maximum mortgage payment, and that's 10% of this one. And the maximum mortgage payment is 30% of this one. So 75000 times 0.3 is, I said plus, not times. Times 0.3 is 2, nope, not that one. Gross monthly, 30% of the monthly payments. Sorry. 6250 times 0.3. Can have a mortgage payment of $1,875. If the mortgage interest rates are 4.5% for 30 and 3.75 for 15, how much could they borrow for each type? So now we're using this formula to find out how much they can borrow if the payment is, for a mortgage, $1,875. So how much could they afford to borrow if the payment, let's see if I can move that down a little bit. Payment is $1,875 times 1 minus parenthesis 1 plus APR for the 30-year mortgage is 0.045 over 12 to the negative 12 times 30 divided by APR 0.045 divided by 12. To do it for the 15-year, we'd have almost all the same, except the interest rate would change, and the 30 would be 15. So that would be 1,875 times 1 minus parenthesis 1 plus 0.0375 over 12 to the minus 12 times 15 to get the amount the P could be. Over 0.0375 divided by 12. So let's work those two out. 1875 parenthesis 1 minus parenthesis 1 plus 0.045 divided by 12 close parenthesis to the open parenthesis negative 12 times 30 close parenthesis for the power and another parenthesis for the numerator divided by open parenthesis 0.045 divided by 12. So you can get a $370,000 loan approximately at the 15% or at 15 year. And the other one would be similar. We'd have to go up here and change this to not 0.45 but 375. 37 insert 5 divided by 12 to the 15 year 0.037 insert 5 and it will be a $257,830 loan. Okay, so that's how much of a loan they could afford. What would be the total cost of each mortgage? Well, that would be 30 years times 12 times 1875 here. 30 years, 12 times a year, paying 1875. So the total cost of the loan for the 30-year loan would be 30 times 12 times 1875. Total cost of the loan is $675,000. In the other case, it's not 30 years, but only 15 years, which is going to be half as much, $337,500 for the total cost. 15 years times 12 times a year times payments of $1,875. And at last, it says, if the property values are rising at 4%, calculate the net profit in equity in the home loan. So how much did the house go up? So they put that much money in, and we want to know how much the house will be worth if it's growing at 4% annually. So we'd use this formula with n equal to 1 and 4% for the APR, and we're going to do it for 30 years and for 15 years. So this one we're going to do 370,000 plus 4%, 0.04 divided by 12 to the 12 times 30 years. So that home would be, that portion of the house would be worth 370 parenthesis plus 0.04 divided by 12 close parenthesis to the open parenthesis 12 times 30 close parenthesis. That home, would be worth $1,225,994 ish. So spent $675,000, borrowed only $375,000, so we paid more than double the original loan amount, but the house is now worth roughly 4 times as much, so that would be a pretty good investment. Now the other one, we took out a $250,000 loan, paid $340,000 on it, but the house will be worth that portion, a $257,000 house at times 1 plus, and the house is still growing at 0.04 over 12 to the end, 12 times the number of years, 15. Let's see how much that portion of a house of that value would be. So 257,830 parenthesis 1 plus 0.04 divided by 12, close that parenthesis to the open parenthesis, 12 times 15, close parenthesis. Whoop, typed in something wrong. Oh, got some stuff in here that shouldn't be there. Yeah, I think that's right. No? So the $257,830 loan, that house, portion of that house is now worth $469,328 and some cents. And we've only spent $337,000, and we got a $469,000 house. So that's also a good investment. Okay. And now the last ones. Who wins plurality? So if you remember, plurality has the most first place votes. See, 18, 15, 12, 13, 7. Who's got the most first place votes? A, E, C, D has 20. A has 18. E has 15. C has 12. Looks like D wins the plurality with 20 votes. Who wins runoff? Well, D had 20 and A had 18. That's the second most. So it'd be a runoff between A and D. So let's do the calculations for A and D. A, D. A would have 18 because it beats D in this one. D beats A here, so gets 15. D beats A for the 12. D beats A for the 13. And D beats A for the 7. So D in a runoff wins in a landslide. So D wins this one. And a score of that's 20, 35, 47 to 18. Okay. Sequential runoff. Oh, this one is always a challenge. Who's got the least number of first place votes? Looks like C. So we're going to cross off C's. All the C's go. Now who's got the most first place votes? Or least first place votes? Well, A has 18. E has 15. B has 12. D has 20. So B has the fewest. So all the B's go. Okay. So first out in sequential, first out was C. Second one knocked out is B. Now we got to see who's got the least number of first place votes. My computer locked up again. Okay, now I got it going again. Who's third out? So now, let's see. A has 18. E has 15. E has 12. So E has 27. And then D has 20. A has 18. So now A is out. Because it only had 18. So these, so we'll take out A. So now it's only D and E. And who wins? So D would get 18. E would get the 15. E would get the 12. So E's now ahead. D would get the 13. And D would get the 7. And now I think that's 38 to 27. So D wins in sequential runoff. Okay, so D says do board account. And it says give 5 for first place. So that's 5, 4, 3, 2, 1. We could have done 4, 3, 2, 1, 0. Gives you the same answer. So let's see what A gets. Now I like to lay these out. Let me do it right underneath it. I like to lay it out according to in this order. So A has 18 people giving them 5 points, plus 15 people giving A 1 point, plus 12 people giving A 1 point, plus, so I have the 18, the 15, the 12, now I need the 13 times 1, plus 7 times 2. And I can work out that. And B, I would do 18 times 0, or times 1, excuse me. And then 15 times 4, plus 12 times 4, plus 13 times 2, plus 7 times 4. And I can figure out that one. I do C, similarly D and E, and I should be able to get the points for each one of these and figure out who has the most points, the winner. I'm going to leave that there because I think you can do that. Condorcet or pairwise. That's called Condorcet, but pairwise. So we want to see who wins the most. Well, it looks like A is not likely to beat everybody. So I'm not going to see how A does. I'm going to check and see how maybe who seems to be up high here. D's down, E's E's, E's. It looks like E might be one to consider. So E against A. Who wins? E loses to A. A would get the 18. Oh, can't see what I'm doing here. All right, there we go. E loses to A, and then E beats A. That's 15. E beats A. E beats A, so that's 15 plus 12 plus 13. Even if the 7 went there, it's not going to do it. So E wins this one. How does E do against B? E beats B, gets the 18. E beats B in this one, gets the 18 in the first one. E beats B, gets 15 and 18. That's 33. I think that's going to beat all this because that's only 20, 32. So E is going to win this one. I could go 18 plus 15 plus B wins here, so that's 12 for B. E beats there, that's plus 13, so clearly E is going to win. How about E versus C? I might have trouble getting them all on here. I'll twist it a little bit. E beats C, 18. E beats C, that's 15. E loses the C. E loses the C. Oh, could be close here. And E beats C. Oh, C's the winner there. So E has beat everybody so far. Well, if it beats D, it will be the winner. E versus D. D beats, so that's 18 for D. E beats D, that's 15 for E. So E's hanging in there. E beats D, that's 12. Doing pretty well. D beats E, 13 down here. I think D's ahead now. Let's see. And D beats E, 7. So E didn't beat everybody. Didn't beat D. Is there a chance that D beats everybody? So now we have to check that. So we can go A versus D and see who wins. A gets the 18, but won't get any others. So D will win that because the rest will be over. So D beats A, D beats E, D versus B. D versus B. D beats B, 18. D loses to B, that's 15 for B. B beats D, that's 12. D beats B, 13. And D beats B, 7. D wins against B. D beats E, D beats A, D beats B. Does D beat C? D beats C on the first one for 18. D loses a C, 15. D loses the C, 12. D beats C, 13. D beats C, 7. 20, 38. This is 27. D beats C, D beats B, D beats A, D beats E. D is the Condorcet or pairwise winner. So D is winning a lot of these. Okay. Determine whether this has been gerrymandered. If it now, just because the shapes are not very regular, they're kind of blockish, but this one's kind of stretched out here. Because the shapes are not regular rectangles, or they're kind of weird shapes, different kinds of shapes. Shapes tell us are irregular. So that indicates gerrymandering. And that's actually a guy's name, so it probably should be a capital G. Okay, but how about looking at the balance? So how many A's are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 A's. And there's 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 6. There's 42 total. So there must be 21 B's. So it's evenly split. So the district should be, and there's 1, 2, 3, 4, 5, 6. So there should be 3 and 3, or no worse than 4 and 2 to be reasonable. So let's see if there's how it turns out. This one goes A. This one goes B. This one is B. This one's B. So there's the 3 for the B. Hopefully the other ones are A's. Oop, nope. So it's 4 B's and 2 A's. Oop, that's looking like it. It should be 3 A's and 3 B's. We got 4 B's and 2 A's. So this is a slight, it's not a total indicator, but it's a slight indication of gerrymandering. Okay. Oop, got that off there. Should have been 3 A's, 3 B's. Wasn't. It was 4 B's and 2 A's. It's still not that far off from 3 and 3, so we say it's not gerrymandered, or is slightly gerrymandered. Okay.